All right, I am back. This is Mr. Mac. All right, Algebra 2, Lesson 16.4. And I'll be honest with you, I was staring at this slide before I hit, the video button. And this is a really nice looking slide. I will put this on Edsby for you, okay, so you have a copy of this. But for now, go ahead and copy this y-axis and this x-axis and all of these formulas with the thetas, okay? This is the best things in sliced bread over here. You're gonna wanna keep going to this. This is for finding a reference angle, okay? First thing I need to review with you is this is so cool about higher math. Everything we learn in higher math takes you back to Algebra 1, honestly. And you guys know that these four quadrants, remember, had a number. It was a Roman numeral number. All right, remember here, everyone's positive, positive, and this is quadrant 1. Okay, over here is quadrant 2, here is quadrant 3, and then here is quadrant 4. And if you ever forget, what you can do is put quadrant 1 down. I mean, you know this is going to be quadrant 1. It makes sense. When you first teach people numbers, you're going to teach them all positive, positive. And then look, draw a little counterclockwise C, and that tells you the order. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Oh, and guess what? There's that whole counterclockwise thing. All right, we count 1, 2, 3, 4 in a counterclockwise. Yeah, now you get to see where that comes from. We've been telling you that all this time. Okay, so what is a reference angle? A reference angle is any angle I give you on this circle. We're going to refer it. I like to say refer it to help you remember reference. You're going to refer it back to quadrant 1, okay? So basically, like here, I'll just show you on this diagram. So 135 is over here. It's not in quadrant 1. And I don't know how well you can see this blue, but look, it refers back to the 45 degrees, okay? They're kind of like soulmates, and they have a lot of similarities, okay? All right, it refers back to 45. See this 150? It refers back to 30, okay? Look over here, 210 is in red, all right? It refers back to 30. So we're gonna take all of these angles, we're gonna use a formula to get us the partner, if you will, the reference angle that takes you back to quadrant 1. It's extremely easy, but you just have to memorize these formulas, okay? So look over here. If your angle is less than 90, remember this is 90 degrees right here, okay? If your angle is less than 90, it's going to fall in quadrant 1, and we're just going to call it theta. If your angle is greater than 90, okay, less than 180, it's going to fall in quadrant 2. You're going to use the 180 minus theta formula. If you're larger than 180, less than or equal to 270, you're going to use this formula, theta minus 180. And then finally, if you're larger than 270, then you're going to, and less than 360 or equal to, you can use this formula here, 360 minus theta, okay? So basically, you're just going to use these formulas. Let me circle these quadrants. I don't know, I circled one of them. I don't know why I didn't circle all of them, okay? All right, here we go. So I think I'm gonna slide it right here. So example 1, okay? Let's say I give you 210 degrees, okay? 210 degrees. You just got to figure out where it's going to fall, okay? All right, well, if you spin to here, you're at 90. If you continue and spin here, you're at 180. You notice I keep repeating this. If you spin another, you're at 270. And finally, if you do a whole rotation, you're back to 360, okay? So your 210, I'm going to spin 180, all right, and then I'm going to spin 30 more, so it's going to land in this quadrant. So 210 is going to land in quadrant 3. So you only grab quadrant 3's formula, which says theta minus 180. So I'm going to do 210 degrees minus 180, and I'm going to get 30 degrees. Okay, 30 degrees is what we're looking for. It's the reference angle. Now, let's see how well we did. I gave you 210. 210, I don't know how well you can see it. It's coded in red. See how it's in red? and look, it refers back. Oh, look at that, baby. So 210 refers back to 30 degrees. Okay? All right, let's try another one. Man, did I make a mess out of that. Hopefully you're getting this whole 90, 90, 90, 90. You know, 90 times 4 is 360. I'm not being funny. All right, so let's try another one. Yeah. And again, we've got nothing better to do. All right, so let's say I do a 300 degree angle. Okay, you know exactly where 300 is going to fall. All right, I'm going to put my initial side here. Look, I'm going to spin 270 and 300 will be somewhere in here. Okay? All right, so if it's in quadrant 4, you're going to grab this formula right here and you're going to go 360 minus 300, and the winning answer is 60 degrees as the reference angle. Let's see if I'm full of crap. And it happens, let me tell you. Where's 300, baby? 300 is right here. It's in green. 300 refers back to 60. Wow, this is absolutely, I mean, this is literally the coolest thing we've ever done, honestly. All right, let me erase all this madness. Okay. Let's do an angle that is larger than 360. Oh, Lord. Okay. And I guess I call that all example 1. Oops. Okay, so this will be example 2. All right, I don't know why this number popped in my head. 450 degrees popped in my head. Okay. 450 degrees. And you know what 450 degrees means. It means you're going to spin counterclockwise, right? You're going to do one whole rotation of 360, okay? And then after you do that, you're going to do 90 more, okay? All right, so what do you do if your angle is bigger than 360? Well, hopefully you can read this blue. I don't know why I chose that light color. The given angle, in order for you to find the reference angle, you want to get it in this range. You want your given angle to be greater than or equal to 0, less than or equal to 360. So all you got to do is that coterminal business, and you can add or subtract 360, but in this case, I'm going to subtract 360, okay? I'm going to subtract 360, and that will give me where I'm going with this. And look, that is 90 degrees. Okay, everybody with me? 90 degrees. And that will be your reference angle. Here's what's interesting about one that lands, you know, on the multiples of 90. So if you land like right on this baby right here, you actually can use either formula. Look, if you look at quadrant 1, 90 is 90. But if you land right here in the middle like that, you can plug 90 into the quadrant 2 formula, and 180 minus 90 is also 90. So when they land on the x-axis or the y-axis, you actually have a choice of formulas. Okay, isn't that crazy? But either way, we're looking for the answer of 90 degrees. Let's go ahead and graph that 450, okay? Yeah. It's always good to practice, okay? And I know I've been doing a lot of positive angles, okay? But here, let's go ahead and graph that 450 and make sure I know what I'm doing. Okay, here's your initial side, right? So I want 450, so I'm going to rotate, right, counterclockwise, 360, all right? And then I got to go 90 more. And then I go ahead and I draw that ray like this. But look, you did the one whole rotation and you had to do 90 more. Wait, let's see if I did that right. I don't like the way that looks. Hold on. Okay, hold on. You're going to do one whole revolution, and then there you go. That looks a little bit better. Okay, so here's your 360, and then here is your 90 more. So then it also could be considered 450. Okay, especially if you draw on those loops like that. Okay, see what you can do with this. I am Mr. Mac. Hey, look, I'm halfway. All right, I'm on video 30. Woo! All right, take it easy.